Let's do question 9c. Determine the values of x for which f of x times g of x is less than or equal to 0. So what is the meaning of this? This is a product, f of x times g of x, giving us an answer which is less than or equal to 0. So it means here is either both of them are 0, okay, or one of them is 0, and then again, or one of them is negative, while the other is positive, because they are giving us an answer which is negative. Remember that when you're multiplying two factors, and then the other one is positive and the other one is negative, then the answer is going to be negative. Positive times negative is equal to negative. So because of this here, we're looking at the functions where one function is negative and the other function is positive. Okay, and then the functions, where do they change their sign? The functions actually change their signs at the what? At the point of what? At the x-intercepts. At the x-intercept, that's where they change signs, isn't it? At the x-intercept, they are equal to 0. Right? Remember, graphs or functions, they are continuing. It's not like they're ending there. That's why we put what? Arrows at the end there. See that? We put arrows at the end. Right, now, at this point, g of x is equal to 0. But if you move to the left, you see, now g of x is below the x-axis. So it means it's now negative. If you move to the right of this point, g of x is now above the x-axis. So it means it's positive. And then f of x is equal to 0 at this point. Right, if you move to the left, you see that the graph is below the x-axis. It is negative. But if you move to the right, it's now above the x-axis. It means it's positive up to this point. And then it changes again from being positive to negative now, because it is now below the what? Below the x-axis. So the best thing, what I advise learners to do, is to divide your graphs into regions. Now we're talking about the x-intercept. So we have the x-intercept there. That is the x-intercept of g of x. So we need to find it because we don't have it, right? And then this is another x-intercept there. And then the last x-intercept there. We have this one. We managed to find it. Is 2, 0. You see that? Okay. Now let's find the x-intercept of g of x. G of x is equal to x plus 8. So g of x is equal to x plus 8. And we know that x-intercept, how do we find x-intercept? We know that at the x-intercept, y is equal to 0. So it means y is equal to 0. No, we're looking for x. So y is equal to 0. So 0, this is 0, is equal to x, okay, plus 8. Right, and then it means negative 8 is equal to x. So we can just say x is equal to negative 8. So it means this point here is negative 8, 0. Okay, right. Now, let's look at this region this side, going to the left of or below or less than, when x is less than negative 8, to the right of this line. Where is f of x? Remember, these graphs are continuing. It's not like they're ending there. Where is f of x? It is below the x-axis. So f of x here is negative. F of x here is negative. Negative. Okay? F of x is negative. Even g of x is negative. It's below the x-axis. G of x is negative. You see that? Negative. So let's just write negative or negative for both graphs. And then now we have this region here, which is between negative 8 and 4. Negative 4. Okay, are we including them? Yes, we're including them. So let's say x here between negative 8 and negative 4. Okay, right. Now, if you check here, g of x is positive. and then f of x is negative because f of x is below the x-axis, g of x is above the x-axis. This is the region we want, where one function is positive and the other function is negative. Right, and then we have this region here. Okay, we are including our x-intercepts there. This region is from -4 to 2. Okay, if you check here, f of x, g of x is positive, it's above the x-axis. Even f of x is positive, is above the x-axis. So positive times positive is positive, so we don't want this region. And then when x is greater than 2, going to the right, when x, or let me write this one, I didn't write it. Here is when x is less than or equal to -8. Again, we said we don't want this one because it's negative times negative there. And then here we have x greater than or equals to 2. Right, if you check here, this region, the g of x is positive, but f of x is below the x-axis, so it's negative. You see that? So it means we're saying positive times negative here, which is giving us what? Negative. This is the region we want. You see that? So now we have these two, and that's where the solution is. So it is for, therefore, we want the values of x for which f of s times g of x is less than or equal to 0. So the answer is from -8 to -4. Okay, or from x greater than or equals to 2, not -2, 2. Okay, or you can write it like this, say x element of, these are included, so we use square brackets, the interval notation, and then -4, or you write also, or you can use or union, we use or most of the times, so 2 included, and then up to infinity. You see that? You can write it like that. Okay, so that's what you're supposed to do there. So we're going to meet in the next question.